Hi, I'm Byeolyi, and I'm going to introduce learning facial segmentation from bounding box annotations. Semantic segmentation is pixel-wise image classification to the semantic class each pixel belongs to. While this is a fundamental computer vision research problem, constructing a dataset for segmentation is very expensive since it needs pixel-wise annotations. To reduce annotation burden, facial learning has been applied. FSL aims to learn from a few samples of class of interest. However, in segmentation area, FSL currently relies on fully supervised meta-training setup. That means a large number of full supervision are still required on base classes. Weakly supervised learning approaches do not deal with unseen classes, so we should directly train our network on our class of interest. In this work, we aim to overcome the shortcoming of FSL approach. We suggest using bounding boxes during meta-training in FSL. By doing that, neither full supervisions nor pre-training on class of interest are required. However, background pixels inside bounding boxes disturb the network. To deal with background noise, we propose a novel pseudo trimap estimation. We aim to decompose an image into foreground, gray, and background zone. The gray zone means uncertain region and is excluded from learning. PTE is done by seeing the agreement between a neural network prediction and a bounding box. We define foreground zone as pixels inside the box, predicted as foreground, and gray zone as pixels inside the box, predicted as background. We define the background zone as the outside of box pixels. Based on the suggested pseudo trimap estimation, the attention block is suggested. It estimates pseudo trimap and computes the prototypes by mask average pooling with excluding gray zone from the reference domain. TAP then obtains the prediction of a target domain based on the noise prototypes by measuring attention. By stacking taps an even number of times, trimap-attention module is finally proposed. Masks are refined by iteratively updating target and reference domain and feeding initial mask to a tap. As a result, we get the refined prototypes and predictions for both query and support set. During meta-training, a train episode with bounding box is provided. A tension between the distilled prototypes from TEM and query pixel-wise features forms prediction on query image. We optimize softmax cross-entropy loss between the prediction and pseudo-trimaps for query label. For inference, our meta-learner is evaluated by comparing the query prediction and ground truth segmentation mask on unseen test classes. We evaluate our method on weakly supervised testing setting as well. This shows mean-IoU performances. Baseline stands for the weakly supervised meta-trained model without TEM. We show that our method consistently improves the performances in various datasets and network backbones. Note that ours outperforms baseline in harsher weakly supervised testing scenario. This figure shows the estimated pseudo-trimap representation during meta-training. We can see background pixels inside bounding boxes form gray zone as expected. Ours also gets enhanced segmentation result compared to baseline in complicated sense during inference. To conclude, we suggest weakly supervised meta-training for facial segmentation for the first time so that more annotation-efficient segmentation is accomplished. To eliminate the disturbing background pixels in bounding boxes, trimap-attention-based prototype learning is proposed. Extensive analysis shows the effectiveness and robustness of our method. Thanks for listening.